Let's move on to the next question, that is 13th. If this integral is equal to 1 by 48 e to the power minus 4x cube into fx plus c, where c is constant of integration, we have to find the function fx. Now fx is clearly outside the integral sign, it is there. So what we need? Integral of it, nothing else. So let's start this question. If I substitute here minus 4x cube as t, so I will be getting minus 12x square dx is equal to dt. Now we can write here integral, let us say left hand side I am mentioning with I, is equal to integral 1x square is taken with dx, so that x square dx can be written as minus 1 by 12 dt, right. 1x cube is left, x cube is minus t by 4. So write here minus t by 4 multiplied with dt by minus 12 multiplied with e to the power t, the term already there. So finally we have the result with us 1 by 48 t et minus et plus constant of integration, right. So when you look at this one given to us, it is given as 1 by 48 multiplied with e to the power minus 4x cube fx plus constant of integration. This is clear. So when you compare here, you can clearly see after substituting the value for t, you have here t minus 1 as fx, but t is minus 4x cube, therefore fx is minus 4x cube minus 1. So let us see from the given options, it is there as option number 2. So let us mention and mark as the correct answer. A simple question from indefinite integral. Let us move on to the next question of this paper. On which of the following lines lies the point of intersection of line this one and plane this one? So question is saying you have to first intersect this line and plane, find a point of intersection, and that point is lying on which of the following options. So let us begin this question by saying let this be lambda. So you have a general point on this line as 2 lambda plus 4 comma 2 lambda plus 5 comma lambda plus 3. Now this point is lying on this plane, so that you can find the point of intersection. Substitute this point over here, you get simply need to put plus between all. So you have 2 plus 2 plus 1, that is 5 lambda, 4 plus 5 plus 3, that is 12, is equal to 2, or lambda is minus 2. Once you get lambda, you can put it back to get the point. Therefore point is simply, on substituting minus 2 here, it becomes 0, then 1 and then 1. 0, 1, 1 is the point required. Now let us see all 4 options. When you put here 0, 1, 1, what you observe? It becomes minus 1 upon 1 is equal to, on substituting 1 it is minus 2 upon 2, on substituting 1 it is 5 upon minus 5. So you can see minus 1 equals minus 1 equals minus 1, meaning this is satisfied. When you put this point in any of other options, you will see the sign of equality is not holding good. So the correct answer for this question is option number 1. Let us move on to the next one, that is question number 15. Let S, it is given x comma y such that it is satisfied. So the question is saying what this is actually, hyperbola or ellipse. Now there are two possibilities. One, either 1 is greater than r or r is greater than 1, correct. R is a positive number. So here you need to say either r is between 0 and 1 or r is greater than 1. You have to take the cases. When you say r is greater than 1, it will become ellipse. When you say r is between 0 to 1, it will become hyperbola. Options are also accordingly correct. You have to check with both whether r is greater than 1 or fractional. Considering the case 1, r is greater than 1. So clearly it is an ellipse in that case, and ellipse, the eccentricity is given by square root of 1 minus b square by a square. Now when you say b square by a square, you can clearly see b square is r minus 1 while a square is r plus 1. So right here r minus 1 upon r plus 1, correct. When you take LCM, you can see r plus 1 minus r plus 1 gives you 2 upon r plus 1 inside the root sign. So let's see whether it is available here as an option. Yes, option number 2 is there, meaning the question is talking about an ellipse with the given eccentricity as an option 2. So no need to go for hyperbola, but when you check, you will find some result there as well, some eccentricity which will not be there in options. Let's move on to the next question.